We're going to look at exercise 14a, question 7. Okay, so on the same set of axes, draw a unit circle to center around the origin and indicate the position on the unit circle of each of the corresponding angles. Okay, pi and 4 is 45 degrees. So it's roughly here. This is pi and 4. 3 pi and 4 is 3/4 of a pi. Remember, this is pi. 3/4 of a pi would be pi and 4 less than pi, which is here. So this will be where 3 pi and 4 is. So if I draw this in green, this length, or this angle, not length, this angle would be 3 pi over 4. So that's the position. Now 5 pi and 4 is like 1.25 pi, or pi plus pi over 4, which means that we're at the pi position, we're adding pi and 4. So it's over here. If I go all the way around this way, this will be 5 pi and 4. 7 pi and 4 is almost 2 pi, because if I go 7/4 plus 1/4, I get 8/4, which is 2, right? But we're 1/4 less, okay? So we're in this position, 1/4 less, okay? So it's 1/4 less from 2. So to summarize, we've got 4 positions. This is pi and 4. This is 5 pi, not 5 pi and 4, 3 pi and 4. 3 pi over 4. This is 5 pi and 4. And this is 7 pi and 4. Okay, and they're all pi and 4 from the x-axis. Okay, it's pi and 4 from the x-axis. No, not that way. This way. And pi and 4 that way. Pi and 6 is similar. So pi and 6 happens to be the equivalent of 30 degrees. Now, this is a bit more tricky. This is pi and 6. Okay, so pi and 6 is over here. Oh, I'll just write like that. That's pi and 6 here. That's the angle. Negative 7 pi over 6. So negative 7 pi and 6. Negative 7 pi and 6, if I write as a mixed number, that's the same as negative 6 pi and 6. So it's negative pi minus another pi over 6. So we're going backwards 1 pi. So we go backwards to here, because this is the pi position. And we're going back pi and 6 more than that. So we're actually over here. Okay, so we're actually in this position. 13 pi over 6. Well, how many 6s can you fit into 13? If I write this as a mixed number, 6 goes into 13 twice, so 2 pi times, and we're left with 1 over 6, or 1 pi over 6. Okay, so if I go, because this is a positive angle, if I go forwards 2 pi, so I'm in this position, I can add 1/6. So I'm exactly here. So this is both pi on 6 and 13 pi on 6, the equivalent angles, or the equivalent positions on the unit circle. 17 pi on 6. 17 pi on 6 is how many 6s can I fit in 17? Well, I can almost fit 3 6s in 17, can't I? Okay, so we're almost 3 pi's, okay, because 18 pi on 6 is equal to 3 pi, right? But I'm sorry, but we're not quite there. We're 3 pi, 18 pi on 6, which is 3 pi. That's 3 pi. Subtract pi on 6. Okay. If you didn't know what I'm talking about, 18 pi on 6 minus pi on 6 gives you 17 pi on 6. Okay. So on the unit circle, where am I going to go? Well, it's 3 pi minus pi on 6. So where's 3 pi? So this is 1 pi. So I'm at this position. 2 pi, I'm at this position. 3 pi, I'm at this position. And then you're subtracting pi on 6. Okay, so you go back this way. So it's over here. Okay, so this is equivalent to negative 7 pi on 6, but also 17 pi on 6. Okay, so this is just to give you an idea of equivalent angles on the unit circle. Okay, so it gives you the same, essentially the same position. This is also equivalent to, because it's in the second quadrant, 3 pi, not 3 pi, but 5 pi and 6. Okay, it gives you exactly the same thing. So 5 pi and 6, negative 7 pi and 6, and 17 pi and 6 are in the same position. So it's really important that we understand that concept. So hopefully it helps.